Hello everyone. Today we will do second experiment. We will have to report after this experiment. I will announce the necessary information about the report in the class. The name of this experiment is the Excel law test. Purpose of this experiment is to verify Hooke's law and determine the modulus of elasticity for given material. Firstly, I will mention about the stress and strain diagram for ductile and brittle material. After that, I will talk about the deformation and the axial load. If any ductile material are subject to an increase in load, its length firstly increase linearly. After a critical value of stress, for example, yield stress, has been reached, the specimen undergoes a large deformation and finally specimen ruptures. If any brittle material is subject to an increase in load, the specimen ruptures without any noticeable elongation. So we can say that brittle material failed suddenly. However, ductile material undergoes a substantial deformation before failing, and the situation provides a warning that overloading exists. This situation, you can see that the situation in this figure. Figure 1 belongs to ductile material and figure 2 belongs to brittle material. For ductile material, first part is linear, and after that stress has been reached, yield stress, the specimen undergoes a large deformation and finally rupture. But brittle material, there is no linear part. Ultimate stress has been reached and the specimen in this point rupture. Okay? This figure shows us deformation under axial load. This load axial. We know that stress is equal to P over A, or stress is equal to modulus of elasticity multiplied strain. In addition, strain is equal to P over AA, or strain is equal to deformation over length. Using these two equations, we can write deformation is equal to PR over AA. If we know that load, length, area and deformation, we can find modulus of elasticity for given material, and mean error or absolute error, we can, using this formula, we can find relative absolute error. Okay? So let's start the experiment in this experiment setup. In this experiment setup, this metal, rectangular metal rod is restricted in X and Z direction, but it is free in Y direction. So the support reaction happens these two rods, okay, from statics. For example, this P load and rod 1 and rod 2, this length is L over 2, and F1 is equal to F2 is equal to P over 2. This rod support reaction. Okay? This rod is support reaction. Firstly, I will increase the load 10, 20, 30 and 40 kilogram. After that, I will record the readings on DR gauge 1 and DR gauge 2 and fill in the table. Okay? Delta 1 and delta 2, rod 1 and rod 2. I will start. Firstly, 10 kilogram. 10 kilogram. DR gauge 1 is equal to 4 and DR gauge 2 is equal to 4. After that, 20 kilogram. Gauge 1 is equal to 6. Gauge 2 is equal to 6. 30 kilogram. Gauge 1 is equal to 9. Gauge 2 is equal to 9. And finally 40 kilogram. For 40 kilogram, gauge 1 is equal to 11 and gauge 2 is equal to 11. So final results: 10, 20, 30 and 40 kilogram, rod 1 and rod 2 deformation. Okay? Okay. Using this value, pilot the load and deformation graph. Okay. Load and deformation graph. Deformation and load. 10 kilogram, 4, 6, 9, 11 and 4, 6, 1, 11. This is same. 9, 6, 11, 4, 6, 9 and 11, 10, 20, 30 and 40. Point. Using this value, load and deformation graph and rod 1 and rod 2, load and deformation graph. In this part, we can calculate stress and strain. For this part, area is equal to 28.27 millimeter square and length is equal to 600 millimeter. Okay. For this part, stress and strain calculate. Area is equal to 28.27 millimeter square and length is equal to 600 millimeter. Okay. Stress is equal to P over A and strain is equal to deformation by length. For example, 10 kilograms stress is equal to 10 kilograms multiplied G divided by area. Okay, and strain is equal to deformation, this value multiply 0.01 over 600 millimeters. For what 10, 20, 30 and 40. 10, 20, 30 and 40. Stress is equal to P over A, and strain is equal to deformation over length. Okay? Using this value, rod 1 and rod 2, this table rod 1 and this part for rod 2. Using this value, pilot the stress and strain diagram. Stress and strain diagram for rod 1 and rod 2. Using this value, pilot stress and strain diagram, this point, and draw a best line. Okay, best line, approximately best line. Finally, modulus of elasticity is equal to stress divided by strain. That is slope of the best line. Using the slope of the baseline, we can calculate the modulus of elasticity. Okay, using the slope of the baseline, modulus of elasticity. Finally, in this part, using the modulus of elasticity, calculate the expected value. Deformation measured is equal to this table, okay, and deformation calculated using modulus of elasticity. Calculate that deformation is equal to PL over EA, okay. Now, deformation calculated is equal to PL over EA. E calculated. Area is equal to 28.27 millimeter kare. Length is equal to 600 millimeter, and P is equal to 10 kilogram multiply G, 20 kilogram multiply G, etc. Okay, calculated deformation, and finally calculate the mean error. Finally, today this experiment is over. Thank you for listening to me. See you next experiment. Do not forget to prepare this report. Okay, for this experiment, you will have to add report. I will announce the necessary information about the report in the class. Thanks. See you next.